Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we will be doing 100 true or false question on Form 4 at Maths. Alright, are you ready? We will start the quiz now. In 3, 2, 1, go! First question. All functions are relation, but not all relations are function. Is it true or false? Okay. For relation, we have 4 types, which are one-to-one, one-to-many, many-to-one, and many-to-many. Then for function, by definition, function is a special type of relation where each object in domain has its own unique image in codomain, meaning one object can have maximum of one image. Alright, because the image is very unique. So when we plot them in graph, we can write in ordered pair x, y. Then we look at these 4 types of relation that we have. For one-to-one function, yes, we can write 4, -1. We can also write at -4 or 2, -9. No problem. It should be a function. Then for many-to-one, we can write -5 at, we can write 0, 9, we can write 5, 9. No problem. Should be a function. But for one-to-many, we have 1, 1, and 1, 5 at the same time. For object 1, we have 2 images which are 1 and 5, meaning the images are not unique. So this is not a function. For many-to-many, obviously we cannot write them in ordered pairs. That is why it is not a function. In short, by definition of function, only one-to-one relation and many-to-one relation are function. Therefore, the statement is true. Question number 2. Vertical line x equals to a can represent a function. Okay, I will show it to you. The graph looks like this. Alright. The horizontal axis will represent the domain, while vertical axis or y is the codomain. As you can see, one x value can have multiple y value. So this is a one-to-many relation, and it is not a function. Therefore, the statement is false. Question number 3. Fx equals to 2x means function f maps x to 2x. Obviously, this is true, right? Wrong! We have 2 types of function notation. Let me write it down for you. We can have f of x equals to 2x and f dot dot x, then arrow to 2x. 2 of them have different meaning. For the one with arrow here, it means function f maps x onto 2x. While for the one with equal sign, it means 2x is the image of f under function f. Or like how I read it earlier, f of x equals to 2x. So the statement is false. Number 4. Suppose f is a linear function. F of a plus minus b equals to f of a plus f of b. Okay. I clear some whiteboard. We know that for a linear function, fx can be expressed in the form mx plus c, where m is gradient and c is a constant term. It's a constant. Then f of a will be ma plus c, then f of b will be mb plus c. When we add two of them together, means f of a plus minus f of b, it will be ma plus c plus minus mb plus c. It means we factor out the m, a plus or minus b plus c plus minus c. Then what about f of a plus or minus b? It will be m times a plus or minus b plus c. As you can see, they are not the same. When we take f of a plus or minus f of b, the constant term is either doubled or cancelled out. Therefore, the statement is false. Number 5. Suppose f is a linear function, f of k times x is k times f of x. Okay, according to the logic from last question, it should be false, right? Alright, we'll apply the same method here. F of x equals to mx plus c. So f of k times with x will be m k x plus c. Then k times f of x will be k times mx plus c. So it is equals to m k x plus k c. Alright, as you can see, the constant term is now affected by k and they are not the same. Therefore, the statement is false. Number 6. If negative 3, 1 is the point on the graph of y equals to fx, then negative 1, 1 is on the graph of y equals to f3x. It must be false. The constant term will be affected. Right? Wrong! You have a look. This question is actually different from last question. Last question, we compare f of x and k times f of x. But in this question, we compare f of x and f of k times x. They are not the same. In this question, k will only affect x but not constant c. For example, let's say we have fx equals to maybe x plus 4. Okay, so that f negative 3 will be equals to negative 3 plus 4 equals to 1. Then what about f 3x? It means 3x plus 4. We want the y coordinate to be 1, like fx, right? So 3x plus 4 equals to 1. And 3x equals to negative 3. X equals to negative 3 divided by 3 equals to negative 1. Look at the question. Negative 1, 1, it is true. Number 7. Let fx represent the weight of flour needed to make x cakes, and let GW represent the cost of W kg of flour. When we calculate the cost, composite function gfx is used instead of fgw. Okay, this question is actually testing your concept on composite function. Always remember, for composite function, we will do from right to left. Why? Because gfx means g, then we have a bracket fx. Alright, so we'll find the value of fx first, then we plug into function g. In this question, if we take gfx, it means we will get the weight of flour first, then multiply or whatever by the cost per kg. Makes sense, huh? If we take FGW, well, if you think about it, it doesn't even make sense. Therefore, the statement is true. Question number 8. If gx equals to 2 over x, then g14x equals to x. Another composite function question. Okay? Another question on composite function. Alright, if you see g square x, it means g of x. Alright? Means you plug gx into gx. Okay? In this question, it means ggx equals to 2 over x, which is 2 times x over 2. 2 and 2 cancel equals to x. Then if we have g cube x, is actually equals to g of x, which is the same as g of g square x. We know that g square x is just x, so g cube x will just be 2 over x. Continue. G to the 4th x will be g of g cube x. We know that g cube x is 2 over x, so it will be 2 over x, which is x. Then you see carefully, the steps are exactly the same as g square x, right? So we can conclude for g to the n x, if n is odd, then g to the n x will be 2 over x. If n is even, like 2 and 4, it will just be x. And fortunately, 14 is an even number. Therefore, the statement is true. Number 9. The inverse of the function is always a function. Okay. Alright, inverse function means if I have a function f which maps x to fx, then inverse of it, or we write as f negative 1 will maps fx back to x. Just now we said that only one-to-one and many-to-one relation are function, right? What about the inverse? Okay, I will draw a one-to-one function for you. Example, okay, A will maps onto B and C will maps onto D. Then the inverse of it will be B will maps to A and D will maps to C. This is still a one-to-one relation. Therefore, this is a function. Then what about many-to-one? I will draw one for you. For example, P and Q maps to R. Okay, this is a many-to-one relation, right? The inverse of it will be R maps to P, R maps to Q. This is a one-to-many relation. As we said earlier, one-to-many relation is not a function. If not, it will violate the definition of function. So, the inverse of a many-to-one relation is not a function. Therefore, the statement is false. Number 10. Since graph of inverse function is the reflection on y equal to x, you should know that, right? If the graph of a function and its inverse ever intersect, it will only occur on y equal to x. Okay, to be honest, at first thought, I thought this is correct, but I'm not 100% sure. So I tested out on graph calculator. Okay, this is actually true for a lot of functions until I try y equals to negative x cubed and its inverse y equal to negative of cube root of x, which is equals to negative x to the 1/3. Okay, maybe I plot lines of y equal to x for you also. Okay, As you can see, yeah, they did. They did intersect on y equal to x. There are another 2 intersection points which are not on y equal to x. So we can say that it is not necessary for the intersection of a function and its inverse to be occurred on y equal to x. Therefore, the statement is actually false. Okay, I'll cross this down. Therefore, the statement is false. Number 11. The range of a one-to-one function is the domain of its inverse. You can draw out the arrow diagram to see, and this is true. Nothing much to explain, so I just put true. Number 12. The inverse of GF equals to F inverse G inverse. It is true for all functions. Okay, let's say we have A, B, and C. Okay, function F will map A to B, and function G will map B to C. So, G inverse will map C back to B, while F inverse will map B back to A. From A to C, we will first get the value of fx first. Then we plug it into G, which means this is a gfx. Right? When we want C to come back to A, or the inverse of gfx, which is gf -1 like this, we will first find the value of G inverse first. Then we plug it into F inverse. Therefore, the inverse of GF equals to F inverse G inverse. The statement is true. Number 13. The solutions for ax squared plus bx plus c equals to 0 are x-intercepts of fx equals to ax squared plus bx plus c. This statement is actually true. You can try out on graph. As long as your A, B, C are the same, then you will get the same answer. I guys can check out my quadratic equation series. Alright, the statement is true. Number 14. Okay, determine whether the calculation above is done correctly. Okay, let's have a look. For 4x squared plus 12x equals to -9, then factor out 4x. 4x equals to -9, x equals to -9 over 4. X plus 3 equals to -9, x equals to -12. This is actually one of the common mistakes in exam. Alright, always remember, when we solve a quadratic equation by factorization, or completing a square or using formula, however, make sure the equation is in standard form first. Alright, the correct way to do this question is, we have a 4x squared plus 12x equals to -9. We will move this -9 to left hand side. So 4x squared plus 12x plus 9 equals to 0. Then we can do it by factorization. Okay, 2x times 2x is 4x squared. Then 3 times 3 is 9. So that we will have 6x plus 6x, so it's 12x. So when we factor it out, it should be 2x plus 3, then 2x plus 3. X equals to -3 over 2, x equals to -3 over 2. The calculation is wrong. Number 15. We cannot use the quadratic formula x equals to -b plus minus square root of b squared minus 4ac over 2a when the equation has no real roots. Okay, don't confuse, yeah? No real roots means the quadratic equation has imaginary roots, meaning the discriminant b squared minus 4ac is smaller than 0. Let's say x squared, b, we let it be 0, then plus with a 1 equals to 0. So our a is 1, b is 0, and c is 1. Then x will be -b plus minus square root of b squared minus 4ac over 2a, which is square root of negative 4 over 2. We know that square root of a negative number is undefined, right? But we can do this. This is actually the square root of 4, then multiply by an imaginary number I, okay, over 2. So we know that square root of 4 is plus minus 2, right? Plus minus 2i over 2. 2 and 2 cancel. We'll end up having positive I or negative I. By the way, this I is not in the old syllabus, but they added it in the new syllabus, okay? You guys can check out the textbook. Alright, so positive I and negative I are still the solution for this quadratic equation. It's just that they are not real numbers, okay? So the statement is false. We can still use the formula no matter what. Number 16. See, the imaginary number I is defined such that I equals to square root of 1 or I squared equals to negative 1. Thus, we can say that I to the 75 equals to negative I. Okay, I know the number I is not in the old syllabus, but actually you can use the composite function concept to solve this question. Alright, based on the definition, I equals to square root of. So when we square both sides, we have a I square equals to square and square root will cancel out each other. So I square equals to negative 1. But we want I to the 75. So we'll continue. You multiply by I again. So I to the third power is I square. Then you multiply by I again. We know that I square is negative 1 times with a I. So it's actually equals to negative I. You cannot see the pattern, right? Never mind, we continue. I to the 4th degree is I cube, then multiply by I again. I cube is negative I, then multiply by I again. We'll have a negative I square. What is I square? You see, I square is negative 1. So equals to I square is negative 1, meaning this one here is just equals to negative of negative 1. Negative, negative become positive. So I to the 4th degree is 1. Right. We continue. I to the 5th degree equals to I to the 4th degree. Then you multiply by I again. I to the 4th degree is 1. 1 times I is still I. As you can see, this is the same as the first one, meaning the cycle will restart again. Like the one we did in composite function, remember that question? 2 over x then become 2 over x, x, 2 over x, x, 2 over x, x, blah, 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 blah. You can actually continue to multiply it by I, but I'm not going to do it here. I will just tell you, I to the 6 will be equals to I squared, which is negative 1. I to the 7 will be equals to I cubed, which is negative I. And I to the 8. Oopsie. And I to the 8 will be equals to I to the 4th, which is 1. From observation, we can see that the power of I will cycle through I, then negative 1, then negative I, then lastly 1. Okay? Then now we come back to the question. I to the 75. We just have to divide 75 by 4. Okay? I will do it for you. 75 divide by 4. Then we get the remainder. Okay? Then 4 times 1 is 4. We have 35. We need 8 to get 32. The remainder is 3. So 75 divided by 4 is 18. Then remainder 3. So we just have to take the third number in the cycle, which is negative I. Therefore, the statement is true. Number 17. If P and Q are two roots of alpha square x square plus alpha x minus 1 equals to 0. Then p squared plus q squared equals to 1 over alpha squared. Okay, we need sum of roots and product of roots to answer this question. Okay, this is actually a very popular paper 1 question, but candidates always stuck somewhere in the middle or do careless mistake. But never mind, we'll try it now. Okay, for this question, we know that a is alpha square, then b is a, c is -1. So sum of roots will be, we know that the roots are p and q, so sum of roots is actually p plus q equals to -b over a, which is negative, this is alpha, sorry, negative alpha over alpha square. Alpha and alpha can cancel, equals to -1 over alpha. Then product of roots, which is p times q equals to c over a. C is -1. Then a is alpha square, which is just pq equals to -1 over alpha square. Okay, I will highlight it here. This is p plus q equals to -1 over alpha. Right, now we have p plus q and pq. Then the question 1, p square plus q square. This is where a lot of us make careless mistake. We always do it like this. P plus q square is just bracket p plus q square. So equals to p plus q. I know. -1 over alpha. -1 over alpha square. So meaning 1 square is 1 over alpha square. And I tell you this is wrong. If you expand the bracket here, in p plus q square, you actually get p square plus q square at the back plus 2pq. But we only want p square plus q square, right? So we'll move this 2pq to the other side. Alright, like this. P square plus q square equals to bracket p plus q square minus 2pq. See the difference? See the difference? We don't have minus 2pq here. So p square plus q square equals to p plus q is what? P plus q is -1 over alpha. -1 over alpha square. Then minus 2pq. Pq is, what do we get? Okay, -1 over alpha square. Okay, -1 over alpha square. So -1 square become positive 1 over alpha square is just alpha square. Minus become plus. Then 2 over alpha square. Same denominator. Combine the fraction. 1 plus 2 is 3 over alpha cube. This is the correct answer. The statement is false. Number 18. A quadratic equation always have 2 complex roots. No lah, it can have no roots if b squared minus 4ac is smaller than 0. Right? Wrong! If you look at the question never says 2 real roots. It says 2 complex roots. In my quadratic series, I actually explain what is complex number. Okay, I will just briefly explain it here. A complex number is a number that can be expressed in the form of a plus bi. You know what is I already, right? I is an imaginary number, okay? Imaginary number. Then you tell me, no leh, sometimes the quadratic equation have very nice whole number roots more. For example, we have maybe x equals to 4. But, I will just tell you, this number 4 is actually a complex number. Just that the b is 0. Means it is 4 plus 0, I. Meaning there is no imaginary part. That's why we call this number 4 a real number. Then you ask me again, what about those with only 1 root? Well, algebraically, quadratic equation will always have 2 roots, but they can be equal. For example, the quadratic equation from earlier. Remember this question? It is 4x squared plus 12x, then plus with a 9 equals to 0. The one we did in previous question, right? Then we factor it out into 2x plus 3, then 2x plus 3 equals to 0. So x equals to negative 3 over 2 and x equals to negative 3 over 2. See, we will always have two roots, just that they are equal. And maybe on the graph, you'll only see the parabola cuts at x-axis at one point. That's why we call it one real root. They are actually the same. Okay? In short, we can have, for nature of roots, we can have two real and distinct, means different roots. Two real and equal roots, or sometimes we call it one real root. I will write here, one real root. And we can have two imaginary roots. By the way, imaginary roots cannot be equal, yeah? They are always in conjugate pairs. You can refer to my quadratic series if you want the full detail. It's a very long story there. I am not going to explain here. Alright, the statement is true. Number 19. A quadratic equation can have one real solution and one imaginary solution. I feel like it's wrong. Cannot have a parabola. Okay, maybe I draw it out for you. Which one leg cut x-axis and the other leg don't know go where. And this is not parabola. We know that parabola is always symmetrical, right? So it's impossible for us to draw it out. But don't worry, we will still do algebraic proof. We will consider all three types of nature of roots. Okay? If b squared minus 4ac is equals to 0, then x will be equals to negative b over 2a. So there is only one real root or two equals roots, whatever. If b squared minus 4ac is greater than 0, when we take the square root of it, okay, square root of b squared minus 4ac, it will be a real number. Both of them will be real number. If b squared minus 4ac is smaller than 0, when we take the square root b squared minus 4ac inside, like I said earlier, it will be a complex conjugate pair. Okay, it will be complex conjugate where a plus bi, b not equals to 0. It will be in complex conjugate pairs. So both of them will be imaginary. Therefore, it is impossible to have one real and one imaginary root. False. Number 20. The roots of quadratic equation x squared minus px plus 1 over 4 equals to 0 are real and distinct if and only if negative p smaller than negative 1. Alright, in this quadratic equation, x squared minus px plus 1 over 4 equals to 0, a equals to 1, b equals to negative p, and c equals to 1 over 4. When we take b squared minus 4ac equals to negative p squared minus 4 times 1 times 1 over 4. Negative p squared is just p squared. Then minus this 4 and 4 can cancel. We'll end up having minus 1. We know that square of a number is always positive, right? So p squared is greater or equals to 0. By the way, I write like this because 0 square can be 0. And we can have fraction as a square of a number. For example, the square of 1/2 is 1 over 4. Is smaller than 1, right? Okay? But the question says negative p smaller than negative 1. You just have to flip the sign and take away the negative. So p is greater than 1. From here, if we put these two together, we can know that p squared is always bigger than 1. So when we take, maybe I use a blue color, when we take p squared minus 1, when we take p squared minus 1, since p squared is bigger than 1, so when we use a big number minus a small number, we'll get a positive number means greater than 0. What is this p square minus 1? You see, p square minus 1 is actually b square minus 4ac. b square minus 4ac greater than 0. What does it mean? This means the equation has two real and distinct roots. Therefore, the statement is true. Fx equals to 2x squared plus 2x minus 2 has same x-intercepts and vertex as fx equal to x squared plus x minus 1. Seems correct, right? Because you can factor out the 2 and solve for the equation, right? Wrong! This is a function and not equation. Do you remember, for quadratic equation, ax squared plus bx plus c equals to 0, when we do completing the square, we will first take this constant term c to the other side. So we have x squared plus bx, then negative c on the other side. Then we add a constant b over 2 square to both sides. We can do this because this is an equation. But when we do completing the square for quadratic function, fx equals to ax squared plus bx plus c, we will add b over 2 square and minus b over 2 square on the same side. Why? Because fx is a name for that function, x squared plus bx plus c. I'm sure that you don't want people to simply change your name, isn't it? Like, if your name is Ali, I call you Ali over 2 or Ali minus 2. Do you want it? No, of course. That is why for quadratic function, we will add b over 2 square and minus b over 2 square on the same side so that we don't have to change anything on left hand side, which is the name of that function. Alright, come back to this question. Well, in fact, they do have same x-intercepts. Because if you let the left hand side equals to 0, like you let 0 equals to 2x squared plus 2x minus 2, you can factor out the 2 equals to 0. Then you divide both sides by 2. 0 divided by 2 is still 0, equals to x squared plus x minus 1. Which is the same as the second function, right? So both functions will have the same solution, correct? But what about the vertex? Okay, I will quickly complete the square for you.
For the first function, fx equals to 2x squared plus 2x minus 2. We take out the 2, x squared plus x minus 1. Then we add coefficient of x, 1 over 2 square, then minus 1 over 2 square. Remember the minus 1 at the back, equals to 2x plus half square, then minus, this one should be 1 over 4, minus 1, equals to 2 times x plus half square. This one should be minus 2 times 5 over 4, equals to 2x plus half square minus 10 over 4. Okay, then for the second function, maybe I call it gx, so that I will not confuse myself. X squared plus x minus 1, and x squared plus x plus 1 over 2 square, then minus 1 over 2 square, minus 1 equals to x plus half square. Then this one should be minus 1 over 4 minus 1 equals to x plus half square minus 9 over 4.
The one in green is the first function, 2x squared plus 2x minus 2. And the one in red color is the second function, x squared plus x minus 1. As you can see, they have same x-intercepts, but different vertex. Or to be precise, the vertex have same x-coordinate but different y-coordinate. The statement is false. Different vertex. Number 23. For a quadratic graph, the midpoint between two roots have same x-coordinate as its vertex. It's true, because we know that the parabola is symmetrical. Okay? Then both midpoint and vertex will lie on the axis of symmetry. Let me draw it out for you. For example, this is the axis. Then we have a quadratic curve like this. Y equal to x squared plus bx plus c. Then we have two roots, x1 and x2. the midpoint between two roots and the vertex will lies on the axis of symmetry. So they will have same x coordinate. By the way, you can get this x coordinate easily by using x equals to negative b over 2a. You can watch my videos in quadratic series. I actually explain why in that video. Okay, it's actually another long story. Never mind. This statement is true. Number 34. When the quadratic function f(x) equals to ax squared plus bx plus c is expressed in the form of f(x) equals to a bracket x plus p squared plus q, pq is the turning point of the curve. This is another careless mistake that we always make. To find the x coordinate of vertex, we will let this square term, which is the x plus p square, be 0. Then we take square root on both sides. We'll have x plus p equals to square root of 0 is 0. Then we'll minus p from both sides. X equals to negative p. So the turning point should be negative p q. The statement is false. Number 35. The graph of y equals to bracket x minus 2 square is graph of y equals to x square shifted 2 units to the right. Okay, for this question actually you don't have to plot it out. You can see it directly from here. First thing, the coefficient of x squared for both of them are the same, meaning the shape and the size of the graph for both of them will be the same. Then next, you have a look on their axis of symmetry. For the first graph, y equals to bracket x minus 2 square, the axis of symmetry will be on x equals to 2. Then for the second graph, y equals to x square, the axis of symmetry is x equals to 0. When we compare the axis of symmetry of both of them, we can see that the axis of symmetry shifted 2 units to the right, meaning the whole curve is shifted 2 units to the right. Therefore, the statement is true. Number 36. When the quadratic graph is refracted across y-axis, the y-coordinate of the vertex will not change. Let's say this time I use a smiling curve where a is greater than 0. When we reflect across y-axis, the graph should be somewhere here. Okay. As you can see, for the vertex here, the x-coordinate will become negative. If this is x, y, then yes, the x-coordinate will become negative x because this part here is negative, right? But the y-coordinate will not change. It is still here, same y-coordinate. Alright, so the statement is true. Number 37. If graph of f(x) equals to x squared plus bx plus c has x-intercepts of p0 and q0, then x-intercepts of f(x) equals to negative ax squared minus bx minus c is negative p0 and negative q0. This statement sounds very complicated, right? But actually it means g of x equals to negative f of x. Right, because f of x is ax squared plus bx plus c. When we take a negative in front, we will become negative ax squared plus, not plus. It will become negative ax squared minus bx minus c, which is the same as jx. What does it mean? It means reflect on x-axis. Okay, this time I will use a crying curve for you. Maybe like this. Okay. Then the roots will be here, x1 and not x1. Be sure we'll use the one that they give us, p and q. When we reflect on x-axis, the graph will be somewhere here, right? Maybe I use black color. Something like this. As you can see, the x-intercepts will not change, but the vertex, the y-coordinate of vertex will change. Okay, a quick summary on what we did in last two questions. If reflect on y-axis, x-intercepts and x-coordinate of vertex will change. You need to multiply it by a negative. If we reflect on x-axis, the y-intercepts and y-coordinate of vertex will change. You just have to remember one of them. Then the other one will be opposite. Okay? And this is extremely useful in exam in case of the KBAT question. Alright, so the statement is false. Should be the same, should be P0 and Q0. We don't need the negative. Number 28. Fx equals to x squared plus 3x plus 4 is always positive. Alright, if you look at the function, since a is greater than 0, then meaning it should be a smiling curve like this. Okay? Then it will have a minimum point. This is the mean point. Then we try to complete the square.
Fx equals to x squared plus 3x plus 4 equals to x squared plus 3x, then plus 3 over 2 square minus 3 over 2 square, then plus with a 4 equals to x plus 3 over 2 square minus 9 over 4 plus 4 equals to x plus 3 over 2 square.
Plus with 7 over 4. Okay, so the minimum y value will be 7 over 4. Or I should write out the vertex. The vertex is negative 3 over 2, 7 over 4. As you can see, this 7 over 4 is greater than 0. Mean your x-axis should be somewhere here. Then you have a look on the value of y. Okay, this is y. It will always be positive, right? Therefore, the statement is true. Number 29. Quadratic function fx equals to x squared plus bx plus c is negative for all values of x if a smaller than 0 and b squared minus 4ac is smaller than 0. Okay, if a smaller than 0, if a smaller than 0 means it is a crying curve like this, and we will have a maximum point. If b squared minus 4ac is smaller than 0, means the graph doesn't touch x-axis. It's either above x-axis or below x-axis. But since we already said it has a maximum point, it is a crying curve, so it should be like this. Then you have a look on all the y values. They are all negative. Therefore, the statement is true. Number 30. Determine if the inequality is solved correctly. Okay, I'll clear some space here. Then we zoom in image. Okay, solve for x greater than 1 over x. Multiply both sides by x. Factor into 2 brackets. Then x is greater or equals to negative 1 or x is greater or equals to 1. Obviously, this is wrong because this is an inequality and not equation. You cannot do this. The correct way to do it is, let me show you. X greater or equals to 1 over x. Then you subtract 1 over x from both sides. So x minus 1 over x is greater or equals to 0. Next, you combine into one fraction. X squared minus 1 over x is greater or equals to 0. As you can see, on top it is just a squared minus b squared, which is a plus b, a minus b. I like this formula so much, you know. So, x plus 1, x minus 1 over x is greater than 0. Can we multiply both sides by x? No, this is not an equation. Okay? So I will use a sign diagram. It's actually in the new syllabus, but I will show it here. Sorry, my drawing is really terrible, so I will use this slide to explain. Alright, this is a graph of x plus 1, x minus 1 over x. As you can see, as x equals to negative 1 and x equals to 1, y will be equals to 0. Next, when x is smaller than negative 1, y values will be negative. When x is in between negative 1 and 0, then y is positive. If you extend the graph, this region here is actually a vertical asymptote, meaning the curve will go to infinity without touching y-axis. Then in between 0 and 1, the y values will be negative. When x is greater than 1, y values will be positive. According to the inequality, we want a region that is greater or equals to 0. From the sign diagram, we have two positive regions, which are x in between negative 1 and 0, the one in blue color, and x greater than 1. Don't forget the equal sign. When x equals to 1 and x equals to negative 1, y equals to 0. Therefore, the range of x will be negative 1 smaller or equals to x smaller than 0 and x greater or equals to 1. And this is the correct answer. The steps here are wrong. Now, if y equals to k intersect y equals to absolute value of 3x squared minus 24x plus 36 at 4 distinct points, then k is in between 0 and 12. Okay, we want to know the coordinate of vertex. In previous question, we know that the x coordinate of the vertex is equals to the midpoint of 2 roots, right? So 2 plus 6 over 2 is 8 over 2 is 4. Then we substitute into the equation. 3 times 4 square minus 24 times 4 plus 36. Press calculator, equals to negative 12. Right? Then you take the absolute value of it, it will be 12. So, for the curve, I draw it here. The coordinate of vertex here will be 4, 12. Then you look at the question. Y equals to k means it is a horizontal line. Intersect at 4 distinct points means the line should be here or here or here or here or here. As long as it cuts at 1, 2, 3, 4 points. Doesn't matter where. So, the range of k should be in between 0 and the 12 here. Check whether it can be 0. No. If k equals to 0, it will only cut the curve at 2 points, which is the roots. These 2 points. What about the vertex? If y equals to 12, it will only cut at 1, 2, 3 points. So k cannot equals to 12. Therefore, the statement is true. 32. A system with a parabola and a straight line always have 2 real solutions. Okay, this is only true when the lines cut the parabola at 2 points, like this. If this is the parabola, the straight line like this, and it cuts at 2 points, then it will have 2 real solutions. But the system can have only 1 real solution, which is the one look like this. You see? The line and the curve only intersect at 1 point, then we have 1 real solution. Or the system can have no real solution at all, meaning the line and the curve doesn't intersect. Okay? And this is what we learned in quadratic function, b squared minus 4ac, right? Consider a quadratic function. Y equals to ax squared plus bx plus c. And a straight line function or linear function. y equals to mx plus, maybe I don't use c here because c is already in the quadratic function. I use k. Okay, mx plus k. As you can see, on left hand side for both of the equation, we have y. So we can put them together. Ax squared plus bx plus c equals to mx plus k. Then simplify. Ax squared plus bx, move this to the other side, minus mx, then plus c, move k, minus k equals to 0. Then we can factor out the x for this part. X squared plus b minus mx plus, I put a bracket for it, c minus k equals to 0. You see, this is actually in quadratic equation standard form. This is your a, this is your b, this is your c. When we take b squared minus 4ac, meaning we take b minus m squared minus 4a, then c minus k. Then if it is greater than 0, then means there is 2 real solutions. If it is equals to 0, means there is only 1 real solution. If it is smaller than 0, means there is no real solution. So the statement is false. It can have one solution or no solution at all. We can form number 33. We can form 3 equations from 2u plus 3v equals to 2v squared plus uv plus 2 equals to u plus v. But only 2 are needed to find the solutions. Okay, we try to see how many equations we can form from this. Okay, first equation, 2u plus 3v equals to 2v squared plus uv plus 2. Second equation, I take the first part and last part. 2u plus 3v equals to u plus v. Third equation, I take the second part and third part. 2v squared plus uv plus 2 equals to u plus v. Now you have a look on the power. The highest power involved is 2. Right? And we know that the number of solutions for a system of equation is actually the product of power. In this case, the power of u is 1. The power of v is 2. 1 times 2 is 2. Therefore, there is 2 solutions for this system of equation. Since it only has 2 solutions, meaning we only need 2 equations to find the answer. Therefore, the statement is true. Number 34. System of linear equations with 3 variables have 1 solution if the planes are identical. Okay, this is one of the topics in Form 4 new syllabus. I actually explained in detail in my video on Gaussian elimination. So I will just explain briefly here. The system will have only 1 solution if the plane intersect at only 1 unique point. But if the planes are identical, meaning the functions are the same, so the system will have infinite number of solutions because the planes are stacking on each other. The statement is false. Number 35. If y plus 3 over x minus 2 equals to x plus 2 over y minus 3, then x squared minus 4 over y squared minus 9 equals to 1. You look at it carefully. When you cross multiply, maybe I write it down for you, y plus 3 over x minus 2 equals to x plus 2 over y minus 3. Okay, in order to solve it, we will cross multiply, right? Like this. Okay, cross multiply, we'll have a y plus 3, then times with a y minus 3. Then the other side, we have x plus 2 times x minus 2. And this is our dear friend. A plus b, a minus b equals to a squared minus b squared. So, on left hand side, we'll have a y squared minus 3 squared is 9. On right hand side, we'll have x squared, 2 squared is 4. And now you look at the question. The question wants x squared minus 4 over y squared minus 9. So we will move this y squared minus 9 to the other side. Okay? And be careful, yeah? This is where a lot of us make careless mistake. When you move this y squared minus 9 to the other side, will your left hand side be 0 or 1? Think about it. Take note, yeah? It will be 0 if we subtract this y squared minus 9 from both sides. Meaning, maybe I write down for you, y squared minus 9 equals to x squared minus 4. We minus this y squared minus 9 on both sides. Minus y squared minus 9. So, on left hand side we will have 0 equals to this, whatever, like x squared minus y squared, then minus 4 plus 9, okay, whatever. It will be 1 if we divide, okay. It will be 0 if we divide both sides by y squared minus 9. The equation we have is y squared minus 9 equals to x squared minus 4. When we divide both sides by y squared minus 9, on left hand side, since the numerator and denominator are the same, so it will become a 1. On right hand side, x squared minus 4 over y squared minus 9 is what we want in the question, right? Equals to 1. Therefore, the statement is true.